Hello everyone, welcome to our presentation on ICIEV 2023. I am Firoza Tabassum from BRAC University, Bangladesh. I am the primary author of paper ID 40 and I have with me Humaira Islam to present our paper. We will be presenting our paper titled as Network Dynamics of Bangladesh Inland Waterways, Augmented with Complex Network Analysis of Vessels and Connectivity. Here is the outline for our presentation. At first, we will talk about our motivation and scopes for this paper in introduction section. Then we will discuss the followed methodology and our findings of this paper. Finally, we have mentioned our major contributions and future scopes for this study. I now invite our another author, Humaira Islam, to present the introduction section of this paper.
Thank you, Firoza. This is Humaira. I will cover the importance of Bangladesh inland waterways. Bangladesh is a neighboring country consisting of approximately 700 people. These rivers are interlinked with three largest rivers, Ganga, Brahmaputra, and Matin. Among 64 districts in Bangladesh, only 31 of them have established ports. There are many benefits of inland waterways transportation. It is economical, has no traffic, and it is the cheapest mode of transportation. For instance, the ticket price from district Dhaka to Borishal by air is $27.04. In Bangladeshi Dhaka is 2015 Dhaka. By road is $4.54, and by waterway it is cheaper, which is $2.27. In Bangladeshi Dhaka, $2.50. In the figure shown, here ports exist and most ports are clustered around the center region, showing lack of connectivity through waterways and inefficient use of it. Port connectivity needs to be studied for better surveillance and to understand the robustness of the network. Previously, many researchers have been conducted on transportation network using complex network analysis. In the study of the statistical analysis of the Indian railway network, which is a complex network where topological properties, most important station bottlenecks have been identified. In the weighted complex network analysis of Pakistan highways, important cities, potential congestion points have been recognized, whereas in the analysis of the United States air transportation, comparison with previous transportation network studies are provided. And in the complex network analysis of inland waterways, network connectivity district-wise, port connectivity, Bangladesh complex network properties of port connectivity supported. In our previous study, we have conducted district-based connectivity where it is shown that 31 districts have ports which are connected through waterways amongst each other. But there are a few limitations in our previous research, as only major ports have been considered, but some districts have multiple ports. Visualization has been conducted based on connectivity. In our study on Bangladesh inland waterways network, we have added frequency of vessels traveling in between the ports considering passenger carrying vessels. Our scope for this paper is to identify the structure, important vessels of vessel augmented Bangladesh inland waterways network (BIWN) and to observe the changes of BIWN compared to the connectivity network. I will now invite our planner of the Firoza to conclude with the rest of the presentation.
Thank you, Humaira, for giving me the floor again. I will now explain the analysis approach of our study. To conduct our analysis, we have followed complex network analysis method. The steps are shown here. To perform analysis, at first we have prepared datasets. Next, Bangladesh inland waterway networks have been generated. Based on generated networks, we have then evaluated complex network properties of BIWN. We have considered both network level and centrality level measures of complex network analysis. Two network level properties, average path length and clustering coefficient, have been evaluated to identify network model of BIWN, and two centrality level properties, betweenness centrality and closeness centrality, have been evaluated to identify port ranking and bottleneck of network. In this slide, we will provide a brief on datasets preparation of our analysis. The data is collected from BIWTA, which stands for Bangladesh Inland Waterways Transport Authority. We have initially accumulated data from BIWTA in 2018, and we have recollected the updated data in 2022. All these data were collected as handwritten data, which were later digitized for our analysis. From the digitized data, we then prepared two metrics for complex network generation, connectivity, and vessel augmented. Connectivity network matrix was built district-wise, where 31 districts of Bangladesh were considered as nodes, If there is any direct connectivity from one district to another, we then count age is equal to 1. Basal augmented network matrix was built port-wise. We have considered 241 ports from 31 districts as nodes. The number of edges are calculated as the frequency of basal traffic between the ports. In the next slide, we have shown generated complex network based on the matrix. We have generated the network using network generation tool Aura. The visualization for connectivity and vessel augmented networks are presented here. Now we will discuss on our results or findings after network evaluation. Our first finding is complex network model identification. We have considered 3 complex network models to conduct our analysis: random, small world, and scale-free network models. In this study, we have calculated network level measures like average path length and clustering coefficient for both connectivity and vessel augmented networks to identify the network model. The results are shown in this table. By evaluating the characteristics of the 3 network models, we conclude our answer as both networks shows properties of small world network. The reason can be stated as both connectivity and vessel augmented networks have high clustering coefficients but low average path lengths, which indicates neighboring ports form clusters among themselves instead of distant ports. The network change after augmenting vessel can be summarized as ports are better connected with only a slight modification to the overall connectivity. Our next scope is about network port ranking. We have calculated 2 centrality measures, betweenness and closeness, to identify important ports in network. This table shows top 10 ports based on centrality measures calculation. We can see Dhaka or Dhaka Sodorghat port is ranked first in both cases with highest centrality values. Second most important port can be said as Chandpur and then Murshidganj, as both these ports can be found at top 10. If we want to check which ports are present within top 10 ports of both centrality measures, then for connectivity network are Shariatpur, Kumilla, Borishal, and Manikganj. And for vessel augmented network, Fotullah, Mirkadin, and Noria. If we compare the port ranking between connectivity and vessel augmented networks, we can say that though major port rankings differ a bit, but topmost ports like Dhaka, Chandpur, and Murshidganj remain same. We also identified the port bottleneck in connectivity and vessel augmented networks. We have considered betweenness centrality for the analysis. In connectivity network, Dhaka port has the highest betweenness centrality value, so it creates bottleneck. In vessel augmented network, Dhaka Sodorghat port again has the highest betweenness centrality value, so it creates port bottleneck. So now we want to conclude our study by summarizing our major contributions of this project. This study contributes in 2 significant ways. First, we have demonstrated an unique dataset of Bangladesh inland waterway network. And next, we conducted network analysis in both network and centrality level with vessel augmentation. We believe this study will provide a better understanding on BIWN structure and also will enable policymakers to take decisions on Bangladesh inland water ports and their connectivity optimization. Before closing the presentation, we want to mention our next direction of Bangladesh inland waterways connectivity analysis. Our future plans include to write an extensive journal on our work by including further network analysis and a web platform based on this analysis so that policymakers can take better decisions. Thank you all for having the opportunity to present our study. And now if we want to welcome if we have any questions.